This episode of the Cloudcast is sponsored by ServiceNow. ServiceNow is changing the way people work. With a service orientation towards the activities, tasks, and processes that make up day-to-day work life, ServiceNow helps the modern enterprise operate faster and be more scalable than ever before. To learn more about the enterprise cloud built to manage everything as a service, please visit www.servicenow.com. And now, on to the show.
Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are. Welcome back to the Cloudcast, coming to you live from our massive studios here in Raleigh, North Carolina. Just me today on a Friday, doing this one kind of a little bit offhand, a little bit off schedule. But we saw an issue kind of popped up on the community this week, and we thought it'd be good to sort of talk about, raise some awareness. So excited to have Kelsey Hightower on the show for the first time. Kelsey, thanks for being on. Everybody, it's funny, about a third of the podcast that I listen to these days, you've been on here recently talking about Kubernetes stuff. So excited to have you on the show.
Awesome. Thanks for having me.
Hey, so first and foremost, for anybody who doesn't know you, give us a quick kind of introduction to what you do. You work over at Google, but what do you work on? What are your passion areas and what are your sort of job areas?
So at a very high level, Google, I definitely try to raise awareness about Google technologies. That's everything from Golang, Kubernetes, to our cloud platform. And my primary job is to help people win with Google technologies. As odd as that sounds, I work on the advocacy team that's aligned with our engineering group. So it allows me to take all of my passion. So many of these things I was talking about or working on before I started at Google, and Google just kind of gives me that platform to inspire people to kind of adopt these technologies and then also help improve our products in the process.
Cool. And we'll get into sort of where you're working on stuff and links to stuff. But there was you'd sent out a tweet yesterday, kind of middle of the day, and it said, there's a lot of application platforms that support Docker images without the Docker daemon. Which one was the first? I have no idea. And it felt like at the time, it's just I think it had to do with, Mesos 1.0 going out there. Mesos had supported lots of different container formats, but now was supporting Docker. And it felt like at the time you were kind of just giving some acknowledgement to the industry. Is that how what turned into a very, very long thread got started?
Yeah, that's pretty accurate. So I try to stay neutral. I'm a big fan of Nomad from HashiCorp, Docker Swarm from the Docker folks, and there's a lot of other runtimes, including Mesos. So Mesos had their 1.0 launch, and they also did it without necessarily running the Docker daemon. So they added support for Docker images, and this is something that other runtimes have done as well, Apsera, the fine folks at Joyent. And we've seen this trend kind of pop up, and it's caused a bit of confusion in the industry, mainly because some people don't really understand a Docker image. So the thing that you use to package and ship your application is different than the thing that's required to run that application. And I think me just trying to provide a little bit of education, letting people know that usually if you build an image, you should be able to run that on any OS that provides OS virtualization for the binary that you put inside of that image.
Right. So we'll link to that thread because the thread got sort of interesting, got a little bit sideways. Lots of people jumped in. Solomon from Docker jumped in. Some folks from Red Hat. But we'll link to that without the goal of this is not to sort of poke at anybody, especially anybody who's not here. But I want to kind of maybe we're going back to sort of a 101 level thing, but just to educate people. So the thing that you use to describe your application is a Docker file. That's essentially a packaging exercise. And then you want to go run that Docker file, that Docker image, that layered image. That's going to go run today on a Linux machine. Help us, for anybody who's kind of new to this. What are the mechanics? What are the things in place at that point to go run it? Does it have to be Docker machine? Can it be some other thing? Help us with this idea of what's the runtime versus the image versus the other components that are needed to run a Docker container, if you will.
All right, so let's take one step back. So one step back to make sure that everyone's on the same level of understanding. On Unix or Linux, right? So on a Linux system, you can create a binary, an ELF binary, and that is a very old standard, probably older than I am. And if you take that binary and you put it on a server, maybe you have to install all of its dependencies. So if you're in a Red Hat system, yum install, libxml, everything you need, and you start that process. And the kernel will take care of it and let you allocate memory, bind to an IP address, whatever you have to do to run that process, right? And to make that experience a little better, people need some type of containment. So one avenue is just to use a virtual machine and put all your dependencies in a VM image and start it up, but that's pretty slow, pretty heavyweight. Then this idea of application containers comes out where let's just bundle my app and all of its dependencies in a logical grouping, create a miniature file system for it, and then we can now start that process with some more kernel features that will allow it to be, isolated from the other applications running in my system. So it's very much like you get on a cloud provider with a bunch of VMs. But now we can do this instead of seconds or minutes to launch a VM. You can do this in, milliseconds.
Right.
So to do that previously was very tedious, right? So you got to use things like LXC. The UX really wasn't there. Docker shows up, and the usability improvement to doing that process we just talked about became super easy. It was amazing. That is like, it's changed the game. So give all credit to Docker for doing that. Now, the confusion is when Docker came to the scene, the UX was so good that most people forgot how it all works, right? Package your application, ship it, push it to a registry, pull it down when you need to run it, and use Docker to manage those processes all without ever logging onto a server. That's just magic. So it seems that this new container revolution requires only the Docker ecosystem in order to work.
Okay. So help us. So this came up, about a year and a half ago, when at the time CoreOS, and I think at the time you were working there, but at the time CoreOS said, hey, there's some aspects of Docker that we think could be improved upon. They created a different container format. I think that's the right terminology. They created something called Rocket, which eventually led the industry to go, hey, you know what? Instead of having a bunch of different formats, maybe what we should try and do is create a standard. And there was this thing created called the OCI, or the Open Container Initiative. Fill us in. Where does that activity to try and create a standard, where does it fall into place in that sort of thing that you just laid out for us in terms of, bundle your application and then run your application?
So from Docker's perspective, they've done a good job in controlling the experience and making it great.
Right.
So you see the Docker logo, you can have a very consistent experience. And that also gives them the ability to move forward and innovate, which they've done. So that's the first thing, is since they control that ecosystem and the UX, they've done a good job of, over the years, continuing to enhance that experience for people, developers, people attempting to do these things in production.
Right.
The only problem, though, is that sometimes if you're a vendor at the time at CoreOS and even now at Google, we can be considered vendors who have chosen to build on top of the Docker engine, right?
Right.
And at the time that most people sought to build on top of Docker, it didn't necessarily have all of these features for like service discovery, cluster management. A lot of that stuff wasn't there. So it felt like at the time, Docker was the kind of common denominator, low level, not really interesting, and all the interesting bits will be built on top. And I think CoreOS kind of went in that direction. You see a lot of the runtime systems and big PaaS or platform systems, they all built on top of Docker. So of course, the pressure starts to come out that, okay, at this point, since we've all adopted a very common technology, kind of like the Linux kernel, we need some way of identifying what will the contract be. What can we all rely on to work, regardless of new features being added, that then we can all go and do our own thing on top, but also have a common ground for interop. And I think that's where the tension lies now. So if you're at CoreOS, to push that forward, we created the AppC, so the application specification, which was around application containers. We wanted to specify a lot was based on Docker because they've proven the model, and producing an artifact that any runtime, so that anyone could run this particular artifact. And the goal would be is that all this could be done with very off-the-shelf tooling. You wouldn't need anything special, and to implement the standard, we chose to build a tool called Rocket. And Rocket would implement AppC, Application Container Specification, and prove out that this thing can work. And also we had a couple of other companies. Apcera was one of the first, I think, to implement Rocket or the AppC specification in their own platform. So it kind of proved out this need for standards. And then, luckily for us in the industry, Docker also agreed that having some form of standardization over parts of the technology, and I think it's really clear that we need to say parts of the technology, not all of it. And a fair point that they make is that there's a lot of room to innovate around this idea of containers and how we manage them. So the goal was to produce a subset of standards around what it means to have a artifact that can be run by multiple container runtimes.
Right.
And that layer was pretty small. It's very close to just having a binary and its dependencies on disk with the configuration on how you should run it.
Okay.
But the value, though, is in something that you can also package and ship around. And that's where the image becomes a little bit more important. It's like Blu-ray only working on a Sony Blu-ray player. That wouldn't be quite a standard, even though Blu-ray disc can be bought by anyone. Anyone can buy a Sony Blu-ray player. But Blu-ray doesn't work unless you can take that disc and put it in a Toshiba player, Samsung player, or whatever other device that can play Blu-ray discs. That's when things become true standards.
Right. And that's where I got a little confused yesterday because, you started out the thread and at some point Solomon jumped in and he said, well, saying something is Docker compatible or Docker supported is only about, 90% sort of true. And, and so I'm sort of thinking through this and totally understand when you're saying, Docker has the right to go innovate. They've obviously done a ton of stuff, everything from, created their own scheduling and clustering technology, Swarm. They've done a lot of really interesting things around security and, give them props for all those. But then you also see, like you said, you've got Mesos, you've got Kubernetes, you've got a number of the PaaS platforms like a Cloud Foundry with Garden and, other stuff that kind of built on that. What is his statement yesterday mean? I mean, should the industry, have some pause here about saying, oh, wait a second, am I starting to make some investments today for my developers or for operations that I should worry about stuff? Or is this something that, this is just a set of details that people need to go dig into a little bit and have some more conversations?
So I kind of left it at, I think we need to have more conversations because I think, to Solomon's credit, he was making an accurate statement that it is a little bit too early to attempt to freeze what we currently have. But on the flip side, any vendor that's attempting to provide production level support needs something stable. And these two things are at odds with each other. So it's not necessarily right or wrong, which I think you've been alluding to, but it is something where people need to really ask a serious question right now. This thing that we're asking everyone to package their apps in, the reason why none of the other platforms are attempting to build their own image specs or build their own container runtimes is because we're all in belief that Docker and the OCI will be that thing that we all can rally behind. If we can only get 90% there with those things, then that is going to open up a different conversation of what do we do about that 10% and what is that 10%?
Right. And I think the thread also brought up, something that should maybe be obvious to people, but sometimes gets forgotten is, there's a difference between, Docker, the tech, sort of GitHub/Docker, the open source, open community technology, and Docker.com, which is, Docker Incorporated, a VC funded private company that's, for profit trying to commercialize aspects of the technology. And I think what you're bringing up is, what entity or community or both should be trying to drive this standard if people collectively think there's no point, there really isn't a need to go creating their own standard. This thing that's in place really, should maybe be that thing.
Right. And just to make sure we're clear, Docker has proven and has done a lot around parts of the OCI standard. The only part really in question right now is this image format, which I kind of believe is probably a little bit more important because most of the core OS virtualization technology, I mean, given the name OS virtualization, lives in the operating system. So what you do between fetching an image and how you run it can be some glue between unpacking that image and using the things that the OS gives you. So I think now what's in question is that can Docker, given, and maybe it's not safe to say all Docker, right? Because the entire Docker company was not on Twitter saying the same thing, right? So it was only Solomon's opinion at the time. And I'm going to say at the time because people's opinions tend to change, and they should based on more information that you get from people. So I think right now let's just have a serious conversation to say, is this image format required across the rest of the industry? Maybe not so much for Docker because they have a really great install base that whatever they do, they're pretty much the de facto standard anyway. But if the rest of the industry feels that now is the time to actually figure it out, I think that is just an isolated conversation we should have. Maybe we all just start from wherever Docker is today in terms of that image format, write that thing down, make sure that multiple platforms can pull it and use it. And you know what? That's largely true today. So this is really almost a non-issue. But I think what kind of raised a few eyebrows is the people that have the most influence on making this successful. How do they feel about this long term? Because it's a hard thing to do, right? The enterprise hasn't completely migrated over to containers. So now is the time to actually kind of collaborate a little bit, show signs of maturity, and kind of stick together because anyone in this container field right now, we're all essentially, pun unintended, in the same boat.
Right. Well, and to a certain extent, and not trying to make any claims or anything, but we tend to see patterns repeat themselves in technology and historically, and we saw this 7-8 years ago, maybe 9 years ago with VMware, where people sort of said, okay, we're talking about low level stuff. We should come up with a standard. There was this thing called open virtualization. I think it was called OVF was the standard, but it never really caught on. And kind of the VMware way of standardizing what a VM looked like, kind of took off, and it had implications on the industry in terms of where the ecosystem could play and so forth. And people can say it was good or bad or indifferent, but you're right. I think it is something that people to be aware of and decide how much implications it would have on them and how important it is for them. So
you brought up a really good point. I want to make sure we all look at that because that is one checkpoint in history where we can say when the steward of that particular initiative doesn't somewhat complete the deal, I don't think it worked out well for them. The fact that a lot of people move to the cloud, and once you go to a particular cloud provider, it isn't very easy to take the same VM image and bring it back in-house.
Right.
So you almost have to pick one or the other or split the workloads. And I'm not so sure the fact that all the cloud providers were not using a VMware-driven standard played out well for them.
Mm-hmm. Yeah. So again, like I said, for some folks, they would look at history one way and others would look at it another way. It definitely, as we're seeing the industry evolve, it sort of had a point in time implication. And because of that, partially because of that, we are seeing technology like containers become much more popular and people like the idea of portability. Hey, real quick, I want to shift gears just a little bit because you spend a huge amount of your time around Kubernetes. Kubernetes is gaining a lot of traction. Version 1.3 just came out. A lot of really good stuff. For anybody who is new to Kubernetes, is hearing about it, you've been doing a ton of really interesting work and everything from people getting started stuff to complicated stuff. If somebody came and knocked on your door tomorrow and said, "Hey, Kelsey, where do I get started?" What's some good pointers of stuff that you're working on, or just things that you point people to for one-on-one level stuff?
So the first thing I do is tell them that Kubernetes is pretty much a cloud platform. It is a cloud operating system, meaning it's much more than just doing deployments and running applications, right? That is the table stakes of all these things. What most people don't realize is that the API of Kubernetes, the unified API and how all things in Kubernetes are built, they allow you to do things like custom schedulers easily. We're starting to see a lot of people in the community show off their custom schedulers. Same thing from any other forms of automation. I just shipped a tool called Kube Cert Manager that automates the provisioning of Let's Encrypt certificates so that any app in your cluster can use it. And it was super easy to do because of the way Kubernetes is built. So once people understand that, then I kind of point them to some of the online workshops that I have. I publish a bunch of tutorials on GitHub. We also have some learning things on Google's site. Red Hat has some great docs. CoreOS has some great docs as well. There's also a book that I'm writing called Kubernetes Up and Running through O'Reilly. And there's so much material because a lot of people only need subsets of Kubernetes, right? If you're a batch platform, maybe you're interested in the Kubernetes job stuff. If you're looking for more of a Heroku-like experience where you just want to kind of package your app and run it and let the system manage it for you, then you may want to look at OpenShift and the stuff that Deis is doing with Deis Workflow that's built on top of Kubernetes.
Yep.
Or maybe you're a company like SoundCloud or Disney's of the world where you've been building your internal system that looks a lot like Kubernetes, but you rather kind of switch gears and jump on the same boat with the rest of the community and just adopt that automation platform and just join the community and build on top. So plenty of entry points for people looking to get started, and it's a very powerful system, so you really got to figure out where you need to start.
Yep. No, that's great. And folks, we'll have links in the show notes to Kelsey's GitHub page, and then like I said, he's been on a bunch of podcasts lately talking about this in depth. So he's been on the Cubecast recently. He's been on the Hot Aisle. He was on the Google Cloud platform a little while back talking about this. So we'll have links to all those. He goes into a ton of really good depth about what is Kubernetes, how does it work, what types of problems does it solve. So we'll keep that. We won't do that today, but Kelsey, thank you so much for all the time today, folks. We'll have a link to the thread that we talked about throughout this. If Docker is something that's important to you, either as an end user or as a vendor who's building systems, or a systems integrator building around Docker and the systems around it, take a look at this thread. Again, we're not looking to raise a bunch of red flags, but it is an interesting conversation piece to have, especially if you're very interested in where's the community going, where might the standards evolve to, and how this might affect you. So definitely go take a look at that. Kelsey, best way for folks to reach out to you or find you, or just kind of keep up with all the cool things you're doing out there?
My DM is open on Twitter, and I share everything I do on GitHub. So I'm welcome to talk with anyone, chat with anyone. I'm very reachable.
Yeah, absolutely, and we can attest to that. So, Kelsey, thanks for being on today, folks. Thanks for listening, and we will talk to you next week.
Thank you for listening to the Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.